Hey guys, welcome back to Chapter 12, Inequalities and Linear Programming. Today we'll look at Exercise 12G, Linear Programming. A quick note on what linear programming is. In a lot of situations, especially business concepts and situations, it is usually really useful to maximize or minimize something. Okay, so if I was running a business, I would want to maximize my profits. If I was producing some sort of good to sell, I would want to minimize my cost for materials, but that might be given any number of constraints. Okay, it might be, for example, if I was making a dress, I would want to minimize how much fabric I need to buy to make that dress from a pattern. If I was selling them, I would want to maximize my profits, okay? Or maybe if I was hiring staff, I would want to maximize profits without having too many staff on a shop floor. So there's lots of really practical concepts and applications for linear programming. But to do that, we first need to consider what an objective function is. So an objective function is the function that we are trying to maximize or minimize given any number of constraints. Usually, especially in these chapters, for this year at least, they will be profit and cost. Before evaluating the objective function, we need to identify the corner points, so the coordinates of the corners of the feasible region. If you need to review feasible regions, please refer back to exercise 12E. In linear programming problems, the maximum or minimum will occur at one of the corners of the feasible region. Okay, this is referred to as the corner point principle. So we're going to use that principle today to complete this example. We're going to find the maximum value of the objective function z equals 5x plus 3y, given the constraints as shown in the feasible region below. So we've been given a graph and we've been given the points of the graph. Okay. Your first step in these kinds of equations, in these kinds of problems, is going to be to set up a table. Okay, so what that table looks like is I'm going to list my points, and those are my corner points, and then I'm going to evaluate the objective function, which is, and I'll write the objective function in the table, z equals 5x plus 3y, for each of those points. Now the points are the corners of the feasible region. So here is the feasible region, we've been given it. It looks to be x is greater than or equal to 0, y is greater than or equal to 0, and then whatever the equations of these blue and green lines are. Okay, the corners are included in the region as well. Okay, hence we've got the solid lines. So our points we're going to evaluate are, let's start with point A, and I write A, 0, 0. So the point A is 0, 0. Evaluating that function, z equals 5 times, and we substitute 0 plus 3 times 0. So I've replaced x and y with 0 and 0 as per the coordinate. And of course, 5 times 0 plus 3 times 0 is 0. The next point, let's move clockwise around, is B, 0, 80. Okay, so we substitute 5 times 0 for x plus 3 times 80 for y, and we get 240 as our value at that point for the objective function. We'll continue clockwise. C is the point 60, 50. So we substitute 5 times 60 for x plus 3 times 50 for y, and at that point we get 450 as the value of our objective function. And finally, point D is 85, 0. So again, we substitute 5 times 85 plus 3 times 0. At this point, the objective function has a value of 425, and you can use your calculator to solve these. You can use your scientific calculator to solve these. So we've evaluated the objective function at each point, or at each corner point, okay? And those have been labeled for us on this particular example. Our final step is to state the solution. So we write the maximum value. So we remember we are maximizing. Oh, that's a funny M. The maximum value of the objective function, which is what we are trying to maximize. This Z, it could be anything. Okay, it could be profit, it could be hours or time, it could be anything. So the maximum value of the objective function, okay, which we write what the value is, which is 450. So we write literally, let me highlight it for you. The maximum, we identify it from the table, literally the biggest number in our solutions, okay, occurs when x equals, and it was this point here, 60, and y equals 50. And that's it. So we state our solution and we state the coordinate points. I don't really need the little comma in there, okay? And again, we identify those points from there. So the objective function is the largest or the maximum at these points, given the constraints on all of our lines, and our lines or our constraints are this line here, this blue line here, has to be greater than y equals 0 and x is 0, okay? That is all there is to it today. We'll be looking at applications of this very shortly. As always, guys, good luck with the work. If you have any questions, let me know, but otherwise I'll speak to you all very soon.